Okay, question 12 has got two proportions. We've been given some facts and we're asked to express C in terms of A. So we've got to set up two proportional equations and then go on from there. So proportional equation 1, A is inversely proportional to b to the power of a third. And proportional equation 2 is that C is proportional to the square of B. So therefore I can say, removing the proportional symbol and replacing it with a constant, I can say that A is equal to K1 over B to the third. The reason I'm using K1 is that the second equation will also have a constant, and they're not necessarily the same. So from this equation, I get that C is equal to K2 B squared. So now using the two conditions of A and B, I can put this pair into equation 1 and this pair into equation 2 and work out what K1 and K2 are. Into 1 sub A is equal to 0.5 and B is equal to 64. Therefore, 0.5 is equal to K1 over 64 raised to the power of a third. It's the cube root of 64. This is 4. So therefore K1 is equal to 2. First of our results. Now do the same for equation 2. Sub and get 15 is equal to K2 multiplied by B squared, which is 25. And therefore K2 equals 15 over 25, which is equal to 3 over 5. So our two equations become A is equal to 2 over B to the third and C is equal to 3/5 of B squared. We've got two simultaneous equations and we need to solve for C. So C at the moment is equal to 3/5 of B squared. That's from 2. And from our other expression, we get that B to the third is equal to 2 over A. So therefore, if we cube everything of this equation here, we get that B is equal to 2 cubed, which is 8 over A cubed. So subbing 3 into 4, we get that C is equal to 3/5 B squared. So this is 8 over A cubed squared, which is equal to 3 times 64 divided by 5 multiplied by A to the power 6. And this is equal to 192 over 5A to the 6th. And that is your answer.